for our rational function, we always want our rational functions in reduced form, and so we want to make sure we can factor it, and then if there are any common factors, to cancel them. Here are numerator factors as an x minus 5 times x plus 3, and our denominator factors as x minus 1 times x plus 1. So there's no common factors here, so we're good to move forward with what we have. For our x-intercepts, we get the zeros of the numerator. So that's x equals 5, which has a multiplicity of 1, and x equals negative 3, which also has a multiplicity of 1. And to write those as x-intercepts, we write them as points, 5, 0, and negative 3, 0. For our y-intercept, we get the zeros of the, we plug 0 into the function. So f of 0 equals negative 15 in the numerator and negative 1 in the denominator. So that's just positive 15. And again, as a point, that's 0, 15. For vertical asymptotes, we get the zeros of the denominator. So that's x equals 1 with a multiplicity of 1, and x equals negative 1 with a multiplicity of 1. For our horizontal or oblique asymptotes, we look at the degrees of numerator and denominator. And here the degree of the numerator and denominator is the same, which means that our horizontal asymptote is y equals the quotient of the leading coefficients, both of which here are 1. So y equals 1 over 1, which of course is just 1. And now we're ready to sketch the graph from all this information. We've got our x-intercepts at negative 3 and at 5. Negative 3 and at 5. We've got our our y-intercept at 0, 15. That's like way up here off of my scale. I'm a little disappointed that I created this graph that way. In fact, let me go ahead and rescale my axis. Let's just do these by twos. So that's 2, 4, 6, 8, 10. That'll just help us a little bit on sketching. So our y-intercept was up at 50, which is right there. And then our vertical asymptotes at x equals 1 and x equals negative 1. So there's our negative 1 and our positive 1. And then our horizontal asymptote at y equals 1. So now we can sketch our graph. Note that the x-intercepts both had a multiplicity of 1, which means that we're just going to cross through the axis there. So to follow the horizontal asymptote and then cross through the axis, so that means I'll be going down here. And same thing on the left. And that's very sloppy, but that's the general shape. And then between these two asymptotes, well, the asymptotes at negative 1 and 1 both had multiplicity of 1, which is odd. So the behavior will be different on either side of each of these asymptotes. So since it's going down on the outsides of these, it'll be going up on the insides. And we've got to go to that y-intercept of 15. So we're just going to kind of have something that looks kind of parabolic there.